So we were dealing with test of significance in my previous class. Today's class we are going to see some very common tests of significance. First of them is the Z test, and it is called as Z test for single proportion. In Z test for single proportion, what we have that we have some sample values, and from the sample values we have proportion of people or proportion of observations who are actually having a particular attribute. And we have some previous beliefs also, and we want to test whether the sample supports the previous belief that we have. These previous beliefs comes in the form of a null hypothesis, and we test these with the help of the null hypothesis. And if it matches the null hypothesis, or if the difference is not very high, then we call that the values are almost equal. Otherwise, we actually tell that the difference is significant. This little difference or this small difference which we call is with respect to the hypothesis, means hypothesis, null hypothesis will tell something, and there is a, for the particular test there is a particular way in which you need to write the null hypothesis. Null hypothesis is generally a hypothesis of equality. For example, if you look here, then what we have is that we have a proportion whose value is P naught, it is known to us from maybe from some past belief, some previous researcher has told, etc. And we want to check whether that is the value of the proportion actually. So we write the hypothesis, as you can see here, that P equal to capital P equal to P naught. So P naught is some value, maybe 0.3 or 0.4. Since it is a proportion, so value will be from 0 to 1. Okay. And so this is our hypothesis. The actual value of P is not known to us. If I know the actual value of P, then there is no issue. Problem is that we don't know the value of P, and but we want to check it out with the help of the hypothesis. So this value is not known to us, and but we have a sample value this, and we want to check what sorry, not sample value, we have a hypothetical value. This is a hypothetical value, and we want to check whether the in the sample the proportion that is given by small p is close to P naught or not. If it is close to P naught, then this value of Z will be very small, and we will call that value of Z as insignificant. So this is the way in which we proceed. Let us have an example. Here two important values are there, which we call as critical values. Now whenever you perform a test of hypothesis, you have to understand the level of significance. Level of significance is how much error you are going to allow in your study. 5% level of significance is good enough. It is conventionally this is most accepted. However, if you go to 1% level, this will make the results less sensitive. So and less prone to error also. So giving a balance between sensitivity and error, 5% level of significance is generally accepted, which is 1.96. So let us do one test on this, then it will be clear to us how this test works. So we have this. The following are the raw data that represent the responses Y for yes and N for no from a sample of 40 college students to the question, do you smoke regularly? Now this is very important. Do you smoke regularly? So accordingly some Y and N. Determine that the population proportion differs from 0.3. 0.3 means 30%. So let us make a story out of it and try to understand the situation. Suppose there is a professor who wakes up in the morning and picks up the newspaper. In the newspaper, in the 4th page, he finds a report that in his college there are 30% smokers. Some author has claimed that in this such and such college there are 30% smokers. To this, the professor got little bit annoyed with this comment and wanted to check it out himself. So he went to the college, and then he will not get hold of all the students obviously in the college, because big college, many students are there. How can he get hold of all the students? And some students might be absent also that day. So what he did is that he came across some of the most common most easily available students, and then asked them, told them, please tell the truth, I want to do this for a survey, not as a disciplinary measure, but please tell me whether you smoke or not. Now some people are telling no, they are marked as N, and some people are telling yes. So yes, this is Y. So he has marked down and he has counted 1, 2, 3, then 4, 5, then 6, 7, 8, then here is 9, 10, 11, 12, and then 13, 14. So he surveyed total 40. So he find a sample of 14 divided by 40. Now this is the proportion that he found in the sample. It is marked by small p. What is the value of P naught is the proportion that has been hypothetically decided, and that is 0.3. So what is the value of this? It will be, I think, 0.32. 0.32. Now the question is whether this difference is close enough. This difference is significant or this difference is insignificant. Insignificant means difference is close enough. So let us look at the test statistic now. So null hypothesis, null hypothesis that number of smokers is 30%, 0.3. Alternative hypothesis, as we already defined, opposes the null hypothesis, and that is not equal to 0.3. Now comes the test statistic. This is the formula. P is the sample proportion. P naught is 0.3. That is the hypothetical value. Q naught is nothing but 1 minus P naught. So 1 minus P naught is 1 minus 0.3. So that is actually 0.7. 0.7. So this comes in place of Q naught. And P naught is 0.3. I know this value. N is the number of observations, that is number of students studied. For this case, here studied 40 students. So all these values I replace here and I find the value of this. After that, you take the mod of Z. That is, if it is negative, you take the mod of Z. So what is the value? 0.035. Now we compare. This is called as the calculated value. Calculated value, because it is calculated from the data set. So this is called as calculated value. Now we compare this calculated value with the table value. So table value is 1.96 at 5% level of significance. Since the calculated value, calculated Z is less than tabulated Z, so we accept the null hypothesis. Accept because here the difference is not large enough. Else it is smaller than 1.96. If it goes up more than 1.96, that means the difference is large enough. Then we will, in such a case, we will accept the alternative hypothesis. But in this case, since the value is less than 1.96, so we accept the null hypothesis. Accept the null hypothesis. Accept it. That means whatever claim was made in the newspaper, that information is correct. That information is correct as tested by the professor. So this is how Z test for proportion is performed. This is called as Z test for single proportion. That means if you want to check a single proportion to a particular given fixed value, so we will use this hypothesis. Next we go to this, the smokers of two cities. So this is another problem. This is a problem of two sample test. Okay, so this is a two sample test. This is also Z test for proportions, but for two samples. So this is nothing but a two sample test for proportion. This is also a Z test. This is also a Z test. So what happens in this test? That in a city of 160 smokers were found from 500 people. That means first sample is 500 where smokers are 160. Second smoker size, the second population size is 100 and the smoker is 30. Now this test can be performed only if both the samples are large. Large means greater than 30. If the samples are greater than 30 each of them, then we can perform the test. So this is called as the Z test for proportions. Okay. Both the samples are sufficiently large. Now here assumptions, both the samples are sufficiently large. So now these are the two proportions that we want to compare. What is the test statistic? The test statistic is given by this formula. And the table value is same as the previous one. That means 1.96 at 5% level, 5% level, and 2.58 at 1% level. Okay, so this is now on computation. If the value that Z gives is less than 1.96, then we'll accept the null hypothesis at 5% level. But if the calculated value is more than 1.96, then we reject the null hypothesis at 5% level and go with the alternative hypothesis. What is P1? P1 is number of smokers in the first sample. What is P2? P2 is the number of smokers in the second sample. What is N1? First sample size. What is N2? Second sample size. What is capital P? It is the pooled proportion. That means in the population, total sample size N1 plus N2, that will come in the denominator. And here X1 is the number of smokers in the first sample, and X2 is the number of smokers in the second sample. So this will give me the value of P. And how to get Q? Q is equal to 1 minus P. So this way I will do the computation. I will replace the value, and accordingly I will get this hypothesis to be tested. So let us go to the hypothesis and the practical problem of solving. So all these things are details is given to you here. So you can see the different values of this is 5%, this is 5% level, two-tailed 5% level. That's why it is further divided by 2. This is two-tailed 1% level. Two-tailed means when your alternative hypothesis is P1 not equal to P2 then. So, and this is one-tailed 5% level, and this is one-tailed 1% level of significance. One-tailed means when P1 greater than P2 or P1 less than P2, this type of alternative hypothesis will be there. So once we do this, then we have this. Let us do this problem now. So go back to the smokers problem. P1 is the proportion of smokers in the first city, and the P2 is the proportion of smokers in the second city, not in the sample. You see, capital P means population. Small p, anything in small letters means sample. For example, capital N1 population size of the first population. Small n1 sample size of the first sample. So that is the way we decide. So by the question we have n1 equal to 500, that is first sample size, n2 equal to 100, second sample size, x1 number of smokers in the first sample 160 out of 500, x2 number of smokers in the second sample that is 30. So based on this we compute the value of the test statistic. So you see here is my test statistic. The formula I have written again. P1, this is 0.32, 160 by 500. P2, 30 by 100, 0.3. Capital P, that is x1 plus x2 divided by n1 plus n2, I have found this. Capital Q, I have found this. Now just I replaced all these values in this expression. Ultimately on calculation we get this. So this is my Z value. Now compare it with this value of 1.96. Compare it with this value of 1.96. So this value, that means the calculated value of Z which I got here, this one, is obviously less than 1.96. So if it is less than 1.96, then as per convention I need to accept the null hypothesis. So we accept the null hypothesis. So what is the null hypothesis? Null hypothesis is H0 P1 equal to P2. I have shown you in the previous slide. Even then you can see this. You see here is your null hypothesis. So we accept the null hypothesis and draw the conclusion that the proportion of smokers in the two populations does not differ significantly. So that is what happens in this, that the two population smokers does not differ significantly. So that is how we reach to the conclusion. So these are two Z tests for proportions. Any doubt you have, you may ask now about Z tests. Okay. Let us go to the next problem. Now let us look at this. This is one sample t-test that we are going to study. One sample t-test is a small sample test. Small sample test means here sample size can be less than 30. It may be more than 30, doesn't actually create any problem, but earlier it was believed that the sample size, small sample size tests cannot be done. But there was a person called, his name was say W.S. Gossett. So W.S. Gossett, he actually developed in 1905. He developed a test which is called as the t-test. Now what happened, there was an issue. He could not publish his work because he worked in a company which did not allow the employees of that organization to publish their work. So he took a pen name, and his name was, took a pen name student, and published his work of how to perform small sample tests for comparing of mean value. And he used the letter T for the test statistic. He used the letter T, and this test becomes later on popular as the student's t-test. T-test. It was not called as Gossett's t-test, but it became popular as the student's t-test. Now, these tests, what these tests can do, this test can actually compare the mean value of a population to a hypothetical value. But obviously, we don't know the population values. That is the problem. So, what we do to understand population values, we go for a sample. Now, if it is sample is large enough, more than 30, then we get good estimates. It is obvious. That more the sample size, better estimates we get. But when the sample size is small, then we cannot guarantee so much about the accuracy of the estimate. So he associated something called as degrees of freedom with the size of the sample. This is the first time someone associates degrees of freedom with the size of the sample, and in this process actually the test becomes applicable for small samples. Now this was a landmark. After that, many small sample tests were developed for different other purposes. But the pioneering work was done by W.S. Gossett, and so its work was very important. Now, let us go to the problem now and try to understand this problem. Then we'll see the formula. We'll go the reverse. Then the other two. Other two we show the formula and then the problem. Here, let us, these days, many people buy online clothes. You must also purchase. I have also purchased from Meesho, Flipkart, Myntra, and then Amazon, etc. I have purchased. Now, one day, some people are there. They are means oversized, which we call obese people. Obese people, very fat. Now, these obese people, they cannot purchase ready-made garments because the highest size available is double XL. They are more than double XL. Now, they go to the mall or to the shop, but their size are hardly available. So they have to get tailor-made cloth. They go to the tailor and purchase cloth and get stitched according to their size. But they have a desire because ready-made garments have better finishing. Now they wanted that, okay, let us have something like that if possible. Now one company, they wanted to catch this particular type of customers, those who are obese people, and want to get dresses stitched for obese people and put it in sale in an online store. Good. Now they hired the tailor who is working there, the tailor master. This is the tailor master who is in, you can see the tailor master. So tailor master, let me also give. So tailor master, so oh, beautiful. Now what happens, this tailor master, he wants, he tells that the obese people has a waist size of 40 inches, because waist, if you look at trousers, waist is a very important thing, because length can be altered, but waist can be altered. It is not that it cannot be altered, but it does not look nice when the waist of a trouser is altered. Now the floor manager or the manager of that particular company who is working on that particular segment of making trousers for obese people wanted to be double share. He did not want to only depend on the experience of the tailor master. So he to bring some man, say who works under him, and told that you go with the measuring tape in and around the city, around the nearby town, and there in the mall, in the market, in the crowd, in the office, you will find some obese people. So take their permission and take the measurement of their waist size, and then let us see whether it matches 40 or not. Whether it matches 40. So comes the problem. Let us look at this. So here a random sample of 10 obese people were collected by those men, obviously, and these were the numbers that were obtained: 38 inch, 42 inch, 43 inch. Now with these 10 measurements, we want to check whether the assumption made or the hypothesis that the Taylor master is telling the system that this is 40 inches, whether it is correct or not. So we have to perform t-test. So what is the formula for t-test? Formula for t-test is this one. This is the formula for students t-test. This is the x bar, the mean obtained from the sample. This is the hypothetical average, that is in this case the hypothetical average is 40 as it is told by the Taylor master. This one I have to compute, and this is the sample size. So this sample size is 10 and this one I have to compute. So these are the values of sizes. We calculate summation x. So summation x is 405.5. We calculate x bar using this formula. After obtaining x bar, next step I calculate x minus x bar. So 38 minus 40 minus 2.5, minus 40.55 minus 2.55, 42 minus 40.55, 1.45. Like this we compute, and then we take a square of this. So this is the square values, and then I require the sum of these values, 28.225. Now what I do, I compute s square equal to summation xi minus x bar whole square divided by n minus 1. So I replace these values here, and then I get the s square values this. Now we take a square root of this and we get it as 1.77. Now we replace the value of this t equal to x bar minus mu naught s by root n. So I replace these values here, s root n I replace here, and ultimately I get the value as 0.98. So this is the value of t. The calculated value of t at 5% level of significance for 9 degrees of freedom is this. Now this is what we get from the table. This value will either be supplied in the question, not either, it will be supplied in the question to you. Since 9df, why 9df? Because there are 10 number of observations. So df will be, degrees of freedom will be equal to 10 minus 9. 10 minus 1, and that is equal to 9. Degrees of freedom is the sample size minus the number of restrictions imposed in it. Here there is a restriction that summation of xi minus x bar will be equal to 0. This restriction is there. So we subtract 1 degrees of freedom, and the degrees of freedom is 9. So 5% level of significance, this value will be supplied to you. Now we compare this one, that is this value, with this value. Now in order to reject the null hypothesis, the value in equation number 1 should be more than this 2.26. But in this case, the value of t is less than 2.26. So we will accept the null hypothesis, and that means we will ultimately decide that what the Taylor master is telling, that is correct. Now in case your t is negative, don't forget to take mod of t. Suppose on computation you get this as minus 1.97. So we'll take mod, this is equal to 1.97. So this is how a random sample we perform students t-test to compare whether the mean that is reflected in the sample is significantly higher or significantly lower than a hypothesized mean value. That means some previous mean value idea which I have or someone else must have told. So this is the purpose of the student's t-test. So any doubt about this? Okay. If not, then we proceed.
Numerical is okay, sir.
Numerical is okay. So you understood the concept. So calculations are very simple. Already thing is recorded. I will put it up in the. Okay. Now these tests, t-test, one sample t-test, two sample t-test. Now we'll see two sample t-test, two independent sample t-test. These are also can be done with the help of SPSS, which I uploaded SPSS videos, but many people are not actually many people, even the quality of video was not good. So I am once again recording and once again putting them up. Two of them are already done. Others I will be doing soon. So there you will see how SPSS can be utilized for solving these t-tests and z-test also. All these things. So here we are seeing how manually we can do this solution. Now this is another type of t-test. This is also another type of t-test. This is called as two independent sample t-test. Obviously it was discovered after students t-test was invented by Fisher, another person called Fisher. But then the concept came from W.S. Gossett, the student. But here two samples are we compared. We compare two samples, but our decision is on the population, not on the sample. But for taking the decision on the population, we take the help of sample. Now here you see many medicine are used which use actually venom. And venom is collected from snakes. Some lizards also have venom. So those are collected and then they are in very small amount they are loaded into the medicine, so that this venom actually helps to improve our health. So suppose let us assume that some researcher is collecting medicine from snakes and he is also collecting medicine from the venom from the snakes and also collecting venom from the lizards. Now you want to find out that on an average who gives more amount of venom, whether snake is giving more amount of venom or lizard is giving more amount of venom, that he wants to find out. So for this purpose actually we are designing this experiment. Now let us see what is the data set. So here it is called as Fisher's t-test. Fisher's t-test are based on two formula are there. One formula tells that okay, this is what is the purpose. The purpose is that the average across the two groups are same. This is the null hypothesis. This is called as the two-tailed alternative hypothesis, which tells not equal to, and this is a right-tailed alternative hypothesis. This is a left-tailed alternative hypothesis. This is left. This is one-tailed. This is also one-tailed. Both of them are one-tailed alternative hypothesis. This is called as the right tail. More specifically, this right tail. This is two-tailed alternative. This is called as two-tailed alternative hypothesis. And this is the null hypothesis. Now this is the first t statistic, t equal to x bar minus y bar s under root 1 by n1 plus 1 by n2, or this is mod t equal to x bar minus y bar under root s1 square by 1 n1 plus s2 square by n2. So this is one t-test, this is another t-test. Same type, purpose is same. This is used if we have some information that the two variances of the two populations are not equal, then we use this one, or else we use this one. So generally we use this one to be at the safe side. Now how to do this? Let us look at this. So here we have the snakes and we have also collected venom from the lizards. So these are snakes. So these are the values of venom that are collected from the snakes, maybe in ml, milliliter. ml. So 1, 2, 3, 4, 5, 6, 7. So 7 snakes. Lizards how many? 1, 2, 3, 4, 5, 6, 7, 8. So not necessarily. So these are 7 in number. So my n1 is equal to 7 and my n2 N2 is equal to 8. Not necessarily they are same in number. They might be same, might be different. Same is only a special case. Now first what we do, we calculate a summation of this and then we calculate x bar. X bar, you see, this is my x bar. First sample total divided by number of observations. So the usual way in which we compute the average. Then 3.8 minus this one, 4.0571, we get this value. Then 4.2 minus 4.0571, we give this value. In this way we get this, all this x minus x bar. Then we calculate x minus x bar whole square. So this just square it up, this one squared up here, this one squared up here, like this. And then we require the sum of this column. So this is one part of the computation related to x is over. Now we come to y, lizard. So lizard, these are the values. So we first calculate the sum of lizard venom, average of lizard venom. Then this is y minus y bar. So 3.9 minus 3.7, this will 4.05 minus 3.71, this will y minus y bar. So y minus y bar whole square, this is equal to, we sum it, all these things, we sum it up, we get. Okay, so we get one value is this one, x minus x bar whole square, other value is y minus y bar whole square. Now this is computation is over. So in the exam, I think you can do the computation in Excel also if you give online exam, or you have to use a calculator. Okay. Now this summation, this value I replace here, this value I replace here, divided by n1 minus 1. Remember, this is not n1, n1 minus 1. So 7 snakes, 7 minus 1 is 6. So I have this one. And then we have this value, we replace it here, and divided by 8 lizards, so n2 minus 1, that is 7, so we have this. So we now have s1 square, we now have s2 square, we now have the value of x bar, we now have the value of y bar also, and n1 and n2 I have here. So I now have all the values required for the formula. In the next slide, I go to the formula and I will just replace the values. So next slide. So this is the slide. Here I replace all the values, x bar, y bar, s1 square, s2 square, n1, n2. All these things, keep the modulus sign on because it will help you to keep yourself free from any negative value. So I get this. Now in the question I will be supplied what is the table value. 5% level of significance, 13 df. Why 13 df? Because snakes are 7, lizards are 8, 7 plus 8 is equal to 15, and minus 1 minus 1. Minus 1 for the first sample, minus 1 for the second sample. So 2 samples are there, so df is 13. So 13 df. So it depends on the sample size. In another problem I may get a sample of size 10 and 12. Then 10 plus 12 minus 2. That means 22 minus 2 will be 20. So that's why. And with df this value will also change. So that's why this value will be supplied in the question. Okay, and we perform this, but z value remains constant because their sample sizes is large. We have nothing to do with df. So that's why z value, it is 5% is 1.96 always. In t it is not like that. It depends on the sample size, that is, it depends on the df, and so this value will be provided to us in the question. This one. Now this value is less than 2.3. So if it is less, then we accept H0. So in this problem, our H0 gets accepted. Okay, our H0 gets accepted. That means the amount of venom produced by snakes and lizard does not differ significantly. Let me show you one interesting thing. You see, this is the average given by, this page has become very dirty. Okay. So I made the page clean, that's why. Okay. Alright. Now here you see, this is the average amount of venom given by snakes because X represents snakes, as you can see. This is the average amount of venom given away by lizards. So because Y is lizards, okay. Now if you look at the average, you will find that snakes are giving little bit more venom than the lizards, isn't it? Because it is 4.05, okay, 4.1 say approximately, and this is 3.7 approximately. So snakes are giving little bit more venom than the lizard. But the issue is that this difference is not significant. This difference is not significant. It is an insignificant difference. This difference is insignificant. So null hypothesis is accepted. Difference, that's why physical difference might not be statistical difference. Statistics tells that there is no significant difference. Why? Because we are studying a sample, but drawing inference about the population. I am studying you for some time. For example, one day I met you, then maybe one day I met you in your office. One day I met you in the class, and then I tell you that okay, now this Chakravarti is not a nice guy. He's not good. He's not not a good worker. He's not a good team man. I tell like this. Then you will tell her, hey, you met me only 2 days. How can you make such a strong comments about? That means that I have seen you only for some moments. Based on that, how can you tell about all these things? You will become angry, because actually this is what I am. I have seen you for very few moments, but I am taking an entire decision on you about your well-being, about your attitude, about your temperament, etc. You will not be happy with this. If I would have watched you for say 3-4 years, then I made a comment, and then you might be angry, but you might also think that okay, he has seen me for so much of time, might be there is some galti in me which he must have watched, like that's why he's making some such comments. So that is the point. That means when we study small samples and take decision, even big samples, and take decision on the entire population, now difference should be significant. Small difference has to be ignored. Now whether small or not, that this table value will tell you. Whether the difference is small or big, what does it mean by small? If I tell that, okay, he is a poor person, what is the meaning of poor? You have to define it. That his per capita income is below these, or means his, say, his per capita income plus all real income, etc., that he has is not at par with this. I have to come with a definition. So when I tell that the difference is significant, insignificant, who is providing the benchmark? The benchmark is provided by the table value. So that is the meaning of 5% level of significance. Okay. Next, so shall we proceed? If you have any question about Prt test. Okay, then we go to the sorry.
Sir.
Yeah. Yes, any question?
No, sir.
Okay, so we go to the next problem, that is a Prt test. Prt test is also a two sample t test, but here the samples are not independent of each other. In the previous case, snakes are giving venom separately, lizards are giving venom separately. Snakes and lizard does not have any connection. Lizard will not think, acha, snake, you have given this much of poison, I will try to give little more. This type of thing will not happen. It may happen in a cricket match. First inning score is 204. Second innings, they will try to score more than 204. Those who have watched IPL yesterday must have seen that CSK scored 204 or something. And then Lucknow came up and scored more runs. So these are dependent. That means for you, depending on the first innings runs of second innings is scored. But snakes and lizards not that way. That lizard will tell that okay, snake, you have given 4.5 ml. I will try to give 4.6 ml. No. They are not related. They are independent, brother. Now here is a Prt test. Here the observations are in pair. Samples are of equal size. Now in the previous one, samples may be of equal size, may not be of equal size, but here sample has to be of equal size. And it is paired means before a situation, after a situation. Suppose so many students are now, all of you are there attending my lecture. I measure your blood pressure. Now you are your pressure will be high now, because all day you were worked in your offices. Now in the evening you are you have to get glued to the class. You might have some other things which are pending, yet you are attending the class, number one. Number two, tomorrow exam is starting, so that is also creating some mental pressure on you. So your pressure will be high. Most of your pressure, suppose pressure is, I measured your pressure. Then after measuring the pressure, I give you some medicine. Say a medicine which is supposed to normalize your pressure level. Like I give you say Telstar 20. Telstar 20. I give. And then I measure your blood pressure after 1.5 hours or after 2 hours. Now, if Telstar 20 is actually working in your body, then it is supposed to decrease your pressure level, blood pressure level, or normalize your blood pressure level. That means the average will show a shift. It may be decrease, or in some cases it might increase. For example, suppose a cricket team is there, say any cricket team, IPL, any team, say CSK. Now CSK, I find that the fitness level of CSK players have gone down. So what I do, I increased, brought a trainer. I measured their running speed. What is the speed? Best way to measure fitness is the speed. Look at the speed of the individual, how fast he runs. So he's running. Okay, oh fine, run, he's running. So we are measuring the speed. We are measuring the speed of say 10 cricketers of that team. Now the trainer gives some training, how you can improve your running, how you can improve your speed, how you should okay, and he gives a training of 7 days, following which I am once again measuring the running speed of these 10 cricketers. Now if the training is effective, then the running speed should increase than what it was earlier. And same individual before and after, not before some individual, after some other group of individuals. No. Same group of individuals before and after. So that we need to check, and we need to go into a before after situation. So that is the purpose of Prt test. Okay. Now let us see that Prt test. So what is the test? So this is the test statistic. The test statistic looks simple. Yes, it's simple only. First you see d bar. D bar means suppose my speed before is x, my speed after is y. Okay. Then x minus y. This is the difference. So this is for me. Like this I will have for other people also. So this is called as di. Xi minus yi. That is for the ith individual, this one. So if I have in my sample 10 people, so I will get 10 values of di. The average of those 10 values is my d bar. HD is the almost standard deviation, you may tell. This is the formula, 1 by n minus 1, di minus d bar. That is the standard di minus d bar whole square. The square root is there. So square root, and then it make s suffix d. S suffix d after taking the square. Then under root n. N is the sample size. Now we get the value of the test statistic here, and then we reject the H naught. If we compare it with the table value, if the value of the test statistic is greater than the table value, then we reject the null hypothesis. What is the null hypothesis? Null hypothesis is that there is no significant difference between the means of the before and after situation. So this is the issue at hand. This is the way in which you do the computation. Let us do one example, then we'll understand the computation better also. Let us take up an example. Okay, now this is a very interesting problem, or many of you will enjoy this problem. A beautician claimed that he can bring around remarkable changes in the faces of people who come to him for a makeover. To test this, 10 people were considered. They were judged by an expert before the makeover and again after the makeover in a 10-point scale. That means a beautician, say in many towns there is a shop, this Habib's. So Habib, he is making a claim that if a lady comes to me or a person comes to me, I will make a makeover, and he or she will look more handsome or beautiful than what he was earlier. Now, as a researcher, I want to test if his claim is correct. So what I do is that I recruit a judge. So one judge comes, say this is the judge. He sits in a table, and when the people come and enter, this is say Habib's. This is Habib's shop. Salon, Habib Salon. Now, when a particular person enters, Habib, before that, this judge is looking at his face. Judge is looking at the face, say looking at the face, and giving a mark. Suppose giving a mark 6 before it. Now this person goes in and Habib does lot of changes in his face. He comes back. When he comes back again, judge again looks at the face and give him a mark. Say now he gives 6.8. So this is the judge is doing, and he has done it for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 individual. First individual when enter 6, coming out 7. Second individual 6.5 when comes out 7. Third individual 7 and comes out 5.5. Means the person is looking uglier than what this is the reverse actually. So this is the situation. If you have not understood the problem, here is one demonstration also. So this lady before, suppose this lady before she enters, she get a mark 6. After she comes out, oh God, she is looking gorgeous. Judge is giving 7. This is Susmita. Oh my, Susmita is so sober, so beautiful. So give mark 7. Oh my God, after makeup she is looking ugly. You see, this is looking so nice, so sober. ऐसे अभी कैसा लग रहा है? She 5.5. Judge is giving. Now this lady, she is earlier not so. Okay, 5. Oh, otta she anata. Look at this. Ayyo, 7. पर ये वन प्रॉब्लम इज देयर, दांत पहले भी बाहर था, देखो इधर भी दांत का कुछ नहीं कर पाया अभी. एनीवे, सो दिस इज ओके. लेट अस go forward. Now we go here. Now we are to test whether mu before is, that is average marks she is getting, not ranked. You see, average marks she is getting out of 10 before and after. This is actually significant or not. This tells null hypothesis tells that not significant. This is significant. Means Habib will want to show that mu after is greater than mu before. Habib wants this. Okay. Now what then? So first we write before values, then we write after values, then find the difference of the two. Then we find the average of this difference. You see, I find the total of this difference here. Total of this difference here. Using this total here divided by sample size n, we get the average here. So this average I am replacing. So di minus d bar, that is 0.75. So 1 minus 0.75, 0.25. 0.5 minus 0.75, that is minus 2.5. Like this we are computing. And the square of this values, individual values squared up. Each value squared up. So accordingly I require the sum of this. So I get this value is giving me n minus 1 divided by 9. So this one. So square it up, 1.844. So this is SD. So I get d bar, I get SD of these values. Now I replace these values in the formula. D bar I have 0.75. SD I get this is not standard deviation like SD. It is S suffix D. Okay. So that one we do, we get this and we get ultimate value 0. Now the tabulated value of n minus 1, that is number of pairs. So 10 people, 10 minus 1 is 9 degrees of freedom at 5% level is this. Now this is the calculated value which is less than the tabulated value of T, 2.26 at 5% level of significance. So we accept the null hypothesis and state that the makeover does not have any significant impact on the improvement in facial beauty. कुछ impact हो सकता है, but that is not a significant impact. Some people might have increased, but overall the effect is not significant because some people are there who actually looks ugly after makeover. So that is the situation, that is what is happening in this particular type of test. In all these tests we have found that null hypothesis is accepted, but this is only an accident that accidentally this all null hypotheses are getting accepted. There are cases when null hypothesis might get rejected also. Any doubt about this particular Prt test? In this exam, this part is not there. Yesterday, I informed the coordinator, Mr.
Sir, for later part, maybe like next after this exam, can you sir like provide some like maybe notes for these tests, like knowing all the differences and all? Because like mathematically, yes, a difference, but like if someone asks like about theoretically, like what can be the difference?
I'll post.
Yes, sir. Yes, sir. Thank you, sir.
Now, today's last test, F test. Now, so far we are dealing with mean. Prior to that, we dealt with proportion. Now we dealt with mean, and now we'll look into the variance. We want to compare the variance of two groups, not mean, but only variance of two groups, because variance is sometimes very important. You see, variance makes the world beautiful. There is variation, and that's why they are beautiful. If you look outside, if you look at the leaves of the tree, you will find that all trees have different types of leaves, and that's why the world is beautiful. Every day is not the same. You wake up, someday you find that it's sunny, someday you find it's cloudy, someday you find it's raining. For example, most of us stay, I think most of us stay in Northeast. So we see the beauty of the nature around, is how it changes. But some places, even in India, some places they are very uniform weather, at least for some months of the year. For example, means when I went to Delhi for my master's program, means during my younger days, then I went to I took a rented house. Then that person, what he's telling, few days I saw same type of weather every morning, because I went in the month of July, quite hot even at that time, because actually April, May is more hot. April, May, June is more hot in Delhi. July little bit change in temperature. But even then it is quite difficult to handle the temperature in Delhi, even in July, especially for those people who goes from Northeast, where the weather is relatively much comfortable. Now I woke up, then what this person is telling me, every day I wake up same weather, early morning, sun rises at around 7, it comes to full glamour by 8:30, and then entire day temperature is almost same, like it is more than 40 degree, and in the evening a little bit it cools down little bit, say it comes down to 35-36 degree. Wind blows at night. Nights are relatively comfortable than the daytime, and every day same weather. Means in Northeast we have seen that, okay, too much of heat, then there will be rain somewhere in between, or some wind, or some even storm maybe, then few days storm, then few days continuous rain. This is what I am telling. Now what is that I talked with an IR that your weather is like this, it's so difficult, every day same type of weather. It looks so boring, there is no change in your weather. Means it is like a routine thing. Then you still no rain will it will rain. When rain it will rain. He tells that 28th June. I was very, means no, 28th July. He told 28th July. I was very shocked. Can rain be told in this way, that it will rain on 28th July? Means it looks so absurd. Means those days where there was no like Google weather report and all. But how can we be so sure that? And I was means I was feeling so awkward. Means I was almost laughing to what he was telling. But then, and I saw that really when 29th July, 28th July came, the clouds from somewhere appeared and it started raining. That means this is the time around which monsoon comes. In the Northeast, monsoon is there, but every time there is rain, because even then, after so much of deforestation, there is still weather is pleasant. And then really on 29th, 28th July, it started raining. Now this is lack of variability. There is no variability, and that does not make the world beautiful. World becomes beautiful because of variability. Means if you look at your friends, they are so different, and this makes your life. If you look at your wardrobe, you will find that there are dresses of so different colors that make your world beautiful. So variation is sometimes very important in life, and in data sets also. So we may want to compare the variation, that where the variation is more, two groups whether they have the same variation or different variation. This is the null hypothesis. Sigma 1 square equal to sigma 2 square. Alternative hypothesis is sigma 1 square not equal to sigma 2 square. Now this is a very simple formula, as you can see this, but there is one trick, that when I have the data set, I will calculate the Sx square. You see almost the formula is same as the variance, Only difference is that here it is n1 minus 1, and instead of n1 1 by n1, it's 1 by n1 minus 1, and here it is 1 by n2 instead of 1 by n2 minus 1, and this is sy square. So this is sx square, this is sy square. Now what happens? That one which is bigger out of these two, first I will compute that, I will put in the numerator. Numerator means upper mein. So I will put in the, so if sx square is more, then I will put sx square in that numerator, and then I will go with this formula. But if sy square is more, then I will put sy square here, and I will go with this formula. So this is the simple thing that we need to do. And here instead of single df, there will be two df. First will be, we don't add up the df here. First df will be related to the first sample, that is the sample which you take in the numerator, and this is the second sample, that is the sample which you take in the denominator. So that is all. So that is the thing of the test, and then we compare it with the table. Okay, let us take a live example here. The brisk walking speed in kilometers per hour of two gentlemen, one with dog and another alone. So this is also important. Morning walk. One walks with the dog and another alone over some randomly picked up days. The last months are provided below. You see, they are not equal in number, like the two sample t test. They are not equal in number. Test if the variation of the speed, variation, not average. Test if the variation in their speed differ significantly. Okay. So one man, he is walking with a dog. Another man, he is walking singly alone. Okay. Now this is the man one is walking with dog. So this is the dog wala. This black data set, dog wala army, and this is akela army. Okay. So this one. So what do we do? How to compute? First we go with x values, then we compute x bar. So we calculate the sum of this value which I replace here. Okay. So this is 37.9, and we calculate x bar. Then I calculate x minus x bar, and then I calculate the square of these values as usual. So I get the sum of this one, and accordingly I calculate sx square. This is from x. So sx square 1 by 9 observations, so 1 by 8. So this is the, okay, fine. Then we go to the second sample. So this is my second sample. Here this I call y. So I calculate the sum of this value here, which is actually the sum of this value is 33.6 that we calculate here. Then we calculate y minus y bar. We replace the value, and then we calculate y minus y bar whole square. Square it up, so we get this. So we take the sum of this is 0.88. We replace it in this formula here. Sample size is 7, so it is 1 by 6, and we calculate this. So out of these two, which one is bigger? This one is bigger. So my f value will be equal to sx square by sy square. So just we replace the value, and then we get the value to be 6.4. Now table value which will be supplied to me is table value is this one. This one 4.1. So calculated value is 6.4, table value is 4.5. So this time, this is the first time we get calculated value of f is greater than tabulated value. So what we do? We reject the null hypothesis. So we reject. So what is the reject? That their averages were same. So we here in this case we reject the null hypothesis and conclude that the variation in the walking speed of the two men differ significantly. So that is how we make a conclusion to this test. So these are most important tests of statistics. So what we have studied today: one sample Z test for proportion, two sample Z test for proportion, then three T test, one single sample T test, that is the obese people case. I gave different examples so that you can remember the tests by their examples. Okay, first two are about smokers, where first one was smoker, but that was related to a college teacher who became angry after reading a newspaper report, went to the college. So that one is single proportion. Then two cities are there. So tale of two cities, smokers of two cities. So that I have given the title, smoker of two cities. So that one. Third one is the obese people, that is one sample T test, which is also called as the student's T test. Next was two independent sample T test, that is the example of snakes and lizard. And third one is the third T test is paired T test, that is Habib's example. So that is the paired T test. And then two gentlemen walking in the road, one with dog, another without dog, and a variation in the speed. Because what happens in why variation? Sorry. Because when you go to the doctor, if you have diabetes, then doctor will tell you that you take walk in the morning. Walk in the morning and do brisk walking. ऐसा ही मत टहलो. You do some brisk walking. So that if you walk briskly, then you will do some amount of manual labor. That will be helpful for decreasing your sugar level. So go for a brisk walk. So that person who walks with the dog, his variation is more. His variation is more. The sample one, you have seen the variation is more. So what he does, some days, sometimes he walk very fast, sometimes he walk very slowly, because he is controlled by the dog. Sometimes dog starts replying to his natural call. So at that time, the person has to wait for the dog to complete it. Sometimes dog meets his friend, dog meets his girlfriend, so he wants to talk to the girlfriend. So this person has to stop. Sometimes dog sees his enemy, want to rush towards his enemy. The person get dragged behind. He has to balance. In order to balance the dog, he has to keep running up with the dog. So for this purpose, he has more variation. But brisk walking, actually, the second gentleman will be more effective, because he bricks. His walk is brisk. His walk is at an uniform speed. So with these words, I would like to conclude, in case you don't have any question. Okay, so I'll put up some study material in your this one, Google Classroom for this. Thanks for watching.